So this lesson will start our unit on logic and reasoning, and this unit's going to be a little bit different because we won't have a whole lot of calculating. We're more going to be working on formatting logical arguments. And so as we're going through this, I want you to think about those DirecTV commercials that I showed you. So we have conditional statements, which when I told you we were going to write our own story, I said that I wanted them in if-then format, and that's so it would be a conditional statement. So a conditional statement is a type of logical statement that has two parts. It has a hypothesis and it has a conclusion. And conditional statements are often written in the if-then format. So we'd say if P, so P is just a variable, anything could be filled in there, and then that's the hypothesis, and the conclusion is then Q. So we're saying if this happens, which is our hypothesis, then this will follow, and that's our conclusion. And so again, P and Q can be replaced with a statement. We're going to use that format because coming up we're going to be changing around these statements, and so that if P then Q is kind of our formula to use. So we have hypothesis. The hypothesis is the independent condition. This is what gets to happen on its own. So if our statement was, if it's raining outside, then you will get wet. The hypothesis or the independent condition is that it's raining. That happens on its own. Yeah, there's other things that cause it, but within our own statement, the raining happens first, and then the you getting wet is what happens depending on the rain. So our hypothesis is independent, and our conclusion is dependent. So the condition dependent upon the hypothesis. So if it rains, that's when you get wet. I want you to make sure that you have all of these definitions written down, and you can also use a highlighter to highlight those important phrases. So conclusion, it always comes after the then if it's written in if-then format, and the hypothesis comes after the if. So we're going to rewrite some statements in if-then format. So this is one of them from the commercials that we watched. It says, when you see things you shouldn't see, you need to vanish. So we'll rewrite it as an if-then statement. And it would be, if you see things you shouldn't see, then you vanish. So some of the statements, we really can just replace some words. Other statements we got to work a little more to get it to be in the if-then format, like the second one. The second one is the sum of the measures of two supplementary angles is 180. So we got to think about what is the hypothesis, what is the independent condition. So what we're saying is if we have supplementary angles, they add up to 180. So our statement would be if two angles are supplementary, then their sum is 180. So when we're writing it in if-then format, we make sure we have the if, the independent condition, the then, followed by the dependent condition. So I want you to try this third one on your own. So I already did an example that closely resembles it. I want you to write your own conditional statement in if-then format and rewrite number 3. Okay, then we have something called a counterexample. And so when we're trying to prove or disprove things, counterexamples are really powerful because if we're trying to prove that, say, something isn't true, all we need is one counterexample. So for a statement to be true and hold every single time, it has to work every time. And if we're able to find one example where it doesn't work, then we know that that statement wouldn't be true. So for instance, I want you to we're going to come up with a counterexample for this conditional statement. So it says if n is a prime number, so just any number n is a prime number, then n plus 1 is not prime. So we're trying to find a counterexample that proves that this is not true. So here is our counterexample. 2 is prime, and when I take 2 plus 1, I get 3. 3 is also prime. So this statement proves that, or this counterexample proves that the statement is not true, because I do have an example of a prime number where I add 1 to it and I get another prime number. So this statement does not always hold true. It may be true in some cases, but it's not always true. Another one would be, if the area of a rectangle is 20 feet squared, then its length is 10 feet and its width is 2 feet. So all I would need to do is come up with an example of a length and width where I could still get 20 feet squared from the area, but they wouldn't be 2 and 10. So remember, area is taken by multiplying. So 2 times 10 is how I get my 20. I want you to come up with your own example of an area of 20 that does not have a length and width of 10. So it could be any other two numbers that would multiply to get 20 as the area, but cannot be 10 and 2. So you come up with your own example here. Okay, so now we're going to be rearranging some statements. So this is where our formula comes in. So we have our conditional statement, if then, and then we have something called the converse. Converse is a form of a conditional statement created by switching the hypothesis and conclusion. So I will give an example of that, but if we're using our formula, if normally it was if P then Q, now it is if Q then P. We're just going to define these first and then we'll give some examples of them. So that's the converse. You can think of the converse, Converse shoes go walking. So if we're forming the converse, all we do is switch them. So the P and Q are going to walk in opposite directions and switch with each other. Then we have the inverse. Inverse is a form of a conditional statement created by negating both the hypothesis and conclusion. So we keep it in the PQ format, but we're going to say not for both of them. So if not P, then not Q. And so you can think of the inverse as the opposite, so we're kind of saying the opposite. Where instead of saying it is this, we're saying it's not this. Okay, and then our last form where we'll be changing things around is called the contrapositive, and this is basically a combination of the converse and the inverse. So a contrapositive is a form of a conditional statement created by switching and negating the hypothesis and conclusion. So I switch the P and Q, and I also negate them. So if not Q, then not P. So I want you to make sure you have these definitions written down. We're going to apply them to some examples in the next slide. Alright, so we're going to rewrite this conditional statement as a converse, inverse, and contrapositive. So the statement is, if you are an East Tech student, then you are a CCSD student. So what I can do, to help me out when I'm doing this, is label the P and Q. So if you are an East Tech student, that is my P. Then you are a CCSD student is my Q. So I can follow the formula of what I wrote in the previous definitions to help me switch these up. So the you are an East Tech student and you are a CCSD student are the parts that I'm going to be moving around. The if and then will stay in their spots. So the converse for this would be, if you are a CCSD student, then you are an East Tech student. So I want you to think about whether these are true or false. So if you are an East Tech student, then you are a CCSD student. This is true because if you go to East Tech, then you're also, East Tech is part of this school district, so you're also a CCSD student. But in the converse, It's not true. So if you are a CCSD student, then you are an East Tech student. I could think of a counterexample. You could go to Desert Pines, you're still a CCSD student, but you're not an East Tech student. So this one is false. So then we'll get to our inverse. Our inverse, remember, we keep them in the place, but we negate them both. So if you are not an East Tech student, then you are not a CCSD student. Well, what do we think about this? Is this true? So could I be not an East Tech student but still a CCSD student? Yes, that example I gave about Desert Pines works to prove that this statement is false as well. And then our contrapositive, where we combine them both, is if you are not a CCSD student, then you are not an East Tech student. So this would be true. If you're not a CCSD student, it's not possible for you to go to East Tech because East Tech is in CCSD. So what I want you to do in the next example is exactly what I've done here. So I want you to write the following statement as a converse, inverse, and contrapositive, and then I want you to evaluate if each statement is true. Remember, we're trying to look for a counterexample. That's what tells us that it's not true. So the statement that you'll be rewriting is, if it is a duck, then it is a bird. So if we underline our P and Q, it is a duck is our P, and it is a bird is our Q. So these are going to be the parts that we're rearranging when we write our inverse, converse, inverse, and contrapositive. And make sure you label them because we're going to be using these on the quiz, and so you'll know which is which when you're taking the quiz. Also, that quiz needs to be completed by 10 p.m. the day before you have class. So make sure you click on the link that was on the Google Classroom post, and I'll see you in class.